All right, we're going to talk a little bit about volume, which is the space enclosed within a surface. I'm going to note here that units can be a little interesting. Now, when it comes to volume, volume has some specialized units like liters, milliliters, gallons, quarts, things like that. But for most of the things that you're going to be calculating, you're going to be using what we call cubic units. So that's going to be things like cubic centimeters, cubic inches, cubic feet, cubic yards, whatever. Let's start. I'm going to start talking about our different formulas. And as always, it's always good to start with some of our basic shapes like a box. So when you've got a shape like a cube or a box, you're going to find yourself with three different things. And most of the time when it comes to your formulas for your volume, you're going to find that you're going to end up with a length and width. You're going to be able to figure out an area, and then you're going to be multiplying it by a height. So what happens here is quite literally all the time you're doing these, you're figuring out what sort of a base what your basic area is, and for a rectangle that would be length times width. So you're figuring out what the area of your base is, in which case, like I said, that's length times width, and then multiplying that by a height. Length times width times height. Sometimes you'll hear this of like length times width times depth. It's another fairly common thing that you're going to hear. So this is just for a rectangular, for basically a box. Well, we've got a bunch of different shapes that we're going to run into. One of and one of the most common ones, or some of the most common ones, are things like cylinders. So for cylinders, you've got this has it has basically a circle as a base. That circle will have a radius, and once again, you're going to have a height. And again, you figure out what the area of that base is, in which case the volume is pi times r squared, and then multiply that by the height. So your volume of a cylinder is pi times r squared times your height. Now note, sometimes they'll give you the diameter and you'll need to find that radius. Just take half of the diameter. Well, now notice here that if I were to think of this, it's a little bit like I've got straight sides, straight up and down, no variation. Well, if you don't have any variation, then it's always just going to be just your plain old height. There's other things that you're going to run into. And a couple other shapes that you're going to into are things like spheres. Oops, E-R-E. A sphere. Now for a sphere, of course, this is just a 3D circle. But once again, you're going to be given a radius. With a sphere, it's not, I don't have a constant cross section every time I divide this up. So figuring out the volume is a little bit different. Here we've got another factor involved, and it's 4/3. And this time it's just going to be pi times your radius cubed. Notice that everything here, I've got three different measurements times each other. I've got length, width, and height, and it's basically, it's a it's horizontal times vertical times, well, and times a depth, something like that. I've got three different things times each other. Every single time, I've got one, two, three things multiplied together, three measurements. Same thing with our sphere. Let's talk about our last one that we should do, and that's going to be a cone. And for a cone, cones are interesting because I've just got a point. It's got a circular base. And I'll have a vertical height as well as having a radius. And cones, once again, they've got another factor involved. In this case, for our volume is going to be 1/3 times pi r squared. So we're again figuring out our base and then times the height. So cylinders and cones, the formulas look a little bit, actually they look a lot alike except for this factor of 1/3. So now we can figure out, now let's talk about some of our strategies. And most of the time it's going to be, or most of our strategies when we're dealing with volume or these three-dimensional shapes, it's going to be in how you break up a shape or how do you split a shape. So things like composite shapes, with composite shapes, one of the most common ones that you're going to run into, or a couple ones that you could run into, are things like stairs or a different box. So you could end up with something like, I could end up with, oh, let's say a Tetris piece. And with this, usually what you're going to do is you can do this as, when I look at this, is I look at this as basically two different boxes. You'll figure out what you'll figure out what lengths you have, whatever. It's always just a matter of splitting your shape, of splitting into your basic shapes. So here I would say, oh, I've got my first length, my first width, and then my first height. This right here would be for the volume of this large box right down here. So I would say, okay, I'll call this box 1, and then I'll add to that box 2. And when I do that, you're going to figure out, okay, I'd have length 2. Notice that these two widths are going to be the same. That's also fairly common. And then you might end up with two things with a common height as well. But whatever. So when you're doing this, you're just going to end up doing length 1 times width 1 times height 1. I use this, I using just sort of 1 to say, okay, here's my first box, here's my second box. And then I'd have length 2 times width 2 times height 2. I'm not multiplying this by 2. This is just to differentiate between these measurements and these measurements. Some of your other composite shapes, you might not be using all of a shape. A couple ones that you're going to run into might be things like a domed silo. So say I've got a cylindrical, say I've got like a cylindrical silo that is topped with a dome. And with that, you're going to end up with, say, a height and a radius. Well, here, when I look at this, I see I've got literally half of a sphere. And then I would be adding to that my cylinder. So my volume is going to be, literally, it's going to be half that of the sphere would be. The radius of these two things are going to be the same, though. So it would be 1/2. Now, a sphere is already 4/3 times pi r cubed. My cylinder, however, is just, it's pi r squared and then times h. That's my volume. And here I can actually reduce things a little bit. So my volume for a shape like this is going to end up being 2/3 times pi r cubed. And then so this would be the hemisphere. And then the cylinder, it would still just be pi times r squared and h. I could also have something like a cone-topped cylinder. And with that, you're going to be given two different heights. So if I've got a cone-topped cylinder, I'd end up with you're going to be given a radius that's going to be common to them both. But then you're going to be given one height of your cylinder, I'll call that, well, I could just call that height 1. But then you're going to end up with another height and that's going to be the height of your cone. Well, guess what? We'll just be adding together the volume of my cone plus the volume of my cylinder. Okay, when you do that, it's just saying, okay, my volume is going to be volume of my cylinder, or actually, I'll do the cone first. Actually, how about I just say cone plus my cylinder. My volume of the cone is, 1/3, and I've still got that pi r squared in there, but then it's times the height of the cone. For the cylinder, I still have that base, that pi r squared, but then I have to multiply that by the height of the cylinder. And abbreviate that a little bit. So when you're doing these, you're going to discover that it's just a matter of looking at these as kind of the combination of multiple shapes, and that will help you figure out what your overall volume is. Alrighty, that's all I've really got for right now, so I'll see you in the next video.